Stanford University.
The goal of our research collaboration is to restore function to people with paralysis. This can be people who have a spinal cord injury, people who have a neurodegenerative disease like Lou Gehrig's disease.
We're able to eavesdrop in on electrical activity and slide a cursor across a keyboard and type out messages.
Our research is focused on an area called the motor cortex. The motor cortex is responsible for generating movement on the opposite side of the body. Even in cases where you have paralysis, those cells, those neurons in that area of the brain are still active.
We can surgically implant a tiny electrical sensor that's made out of silicon that has 100 tiny electrodes that just sits on the surface of the brain, and it's able to pick up on the electrical activity of individual brain cells or neurons.
We record tiny signals from those neurons, those brain cells, called action potentials. We can then take those signals and decode them using a computer. We can manipulate them once they're in digital form like any other data.
So all you need to do is imagine moving your right arm, for example, to the letter T on a keyboard, and it'll slide out to the T. And in addition to that, we're also able to detect when you wish to select that letter T.
Our participants were able to type at rates anywhere from 12 to up to almost 40 characters per minute, which translates to, in the best cases, about 6 to 8 words per minute.
The interface that you could control with these decoded neural signals is really many-fold. So you might instead wish to control a robotic arm. You could imagine also interfacing with your home, wirelessly sending signals to your thermostat, open and close doors remotely. This is really the business of Internet of Things.
It's important to keep in mind that this is a phase 1 study, so this is really a safety study, it's a feasibility study. It's not meant to be the definitive device that one would deploy. It will obviously be important to have these systems be completely implantable, wireless, able to function autonomously, not require a technician to set them up. So these are all areas that we're researching throughout our BrainGate consortium, of which we're a larger part. But I'm very confident that in the not too distant future we'll have systems that are deployable and able to provide help for people with paralysis.
For more, please visit us at stanford.edu.